All right, everyone, I think we're now live. Welcome, my name is Max Katz, and welcome to this IBM Code San Francisco webinar. This is actually our fifth webinar in a series where we teach you about technologies that IBM is highlighting for a joint global developer initiative with the American Red Cross, United Nations Human Rights Office, Linux Foundation, known as Code for Code. And John will tell you more in just a second, but if you would like to learn more, you can click the call to action button that you should see at the bottom of your screen. So this event will be recorded, and the recording will be available right after the session ends, and we will also post a link on our meetup page in the comment section for this event. If you're new to IBM Code San Francisco, we're a team of developer advocates from IBM in the Bay Area, and we host in-person and online meetups, lunch and learn events, workshops, and other developer education events. Just a few guidelines before we start. Let's keep the chat relevant to today's topic. And if you have any questions, please post them in the Ask a Question section. And you can also upvote any questions you would like to have answered. And our John will answer them at the end of the session. And so today I would like to introduce John Walicki, IBM developer advocate. And his session today is Build a Cellular IoT Asset Tracker with blockchain. John, it's all yours.
All right. Well, thank you, Max. And so good morning, good afternoon, everyone. So I'm really delighted that you'll spend the next 30 minutes or so with me. And I'm going to talk about IoT asset tracking. So actually taking a tracking device, attach some sensors to it, and then put this out in the real world and track things through time and space. And so we'll take you through why it's relevant and what we think the use cases are. Then I'll turn to the code itself, and we'll take a look at blockchain, at the particle electron, which I chose. And then we'll also talk about Node-RED and building applications. So a little bit about me and my background. So I'm an IoT guy. I love to build things. And so in my role as a developer advocate, I take boards and I tie them to sensors, and I get the data up to the IBM cloud, and I bring it into Watson IoT platform. I typically will store that data someplace, maybe in a blockchain, maybe in a cloud and database or any other cloud object storage. And then I want to bring it over to Watson Studio where I can do analytics on it, right? Tell me about the environmental conditions of the board, of the sensors, and actually find some insights. So ultimately, I will try to do an end-to-end story. And so as part of that, I'm going to share my screen. And so we'll get started here. And hopefully you all see that. And so first, I'm going to do a quick introduction to Call for Code. And so Call for Code is a collaborative project by the David Clark Foundation, the United Nations Human Rights Commission, IBM, several others, to take developers and have us all apply our skills to solving some of the problems around natural disasters. While we can't prevent a natural disaster, we can be prepared for it both before and after, and hopefully minimize the effects of these disasters. So in that effort, IBM has contributed a number of projects and code patterns that we think are relevant that you might. So if you sign up first as a big prize, and you'd be building some really cool code to help people in distress and need. So we want you to sign up, talk to some first responders, and register and build a project to help. Along that line, IBM has selected 6 technology areas that you might use in IBM Cloud to help you build a solution. One of those topics is IoT sensors. So collect and analyze device sensor data to take preventative actions. And so in this particular code area, for which I'm the code captain, love for you to come and register, and I would be delighted to help you build your project. One of the code patterns is a code pattern, develop an IoT asset tracker. That's why you're here today. And so we're going to jump over to that. We'll jump over to IBM Code, where you're going to find all sorts of exemplars of what you might build. Here's an a solution, not just some sample code, but a solution that you might apply by taking the code and using it. So I created earlier this year an IoT asset tracker. So I bought a physical board. It's a particle electron, and I attached some sensors to it we'll talk about. And I send the data up to IBM Cloud, and I build a whole dashboard. And in my case, I wanted to track perishable goods. So food safety is all important to us. Medical supplies in a natural disaster become really important. So things moving through the real world, environmental conditions that they're exposed to, where they are, and time, those three attributes, where, what, and when, become really important. So go read the blog entry that I composed along with the code pattern. There is a architecture diagram here that you might want to take a look at. So we're going to start with the particle electron. We're going to send that data up to the cloud. We're going to bring it over into IBM Cloud in Node-RED. We're going to ingest that data, write it to a blockchain, and then build an application to play back the where, what, and when in a nice little dashboard. All right, so that's what we're going to do, and it starts with the code. So we'll drop down and give you a description of how it works and what you might build. So the quick highlights here are you're going to configure your particle electron. I've given you in the Git repository the actual tracker code that I use for the particle electron. We'll set up the tool chain there. We'll write it to the board, and then we'll go and set up blockchain. I'll talk about the business area network archive that I've constructed for this perishable network. And then we'll walk through how to build that with the blockchain model and what transactions I'm adding to the blockchain. We'll deploy that in Hyperledger up on IBM Cloud. A couple of different choices there we'll talk about. And then we're going to build an application. All right, we'll use Node-RED and some flows I'll introduce you to so that you can see how it all comes together. Okay, so let's get started. Let's go jump over to the code itself. It's hosted in GitHub/IBM, IoT Asset Tracking Perishable Network with a Blockchain. And there's a set of instructions here. The way I broke this down, I sort of wrote it as a workshop. So there are three sections I mentioned already. So let's build the board. Let's write a little program. Let's build a Hyperledger blockchain, and then let's build a Node-RED app wrapped around this, connecting the board and the blockchain. So dig in quick, and let's go over to the first section. Those of you that are hardware developers, you might be comfortable with taking a board. What I took was the particle electron, and I tied it to some sensors. So in my case, a temperature, humidity. So I've used a DHT11. I've used a Grove sensor. I've used a Dallas DS1820. And so you can connect sensors to the asset tracker. Write this little program, which is in the Git repository, and connect it to it. And I've actually not going to flash the board today. It's already running. You might see in the video that I've turned it on. I'm streaming data up to the cloud. Okay, so you can quickly learn how to build a board. Now we're going to spend a little bit longer amount of time talking about Hyperledger. Hyperledger is an open source and project we contributed to the Linux Foundation, and we've got a whole lot of contributors now building out this Hyperledger fabric, Hyperledger Composer, and a variety of projects wrapped around the blockchain to help manage this permissioned network. Different than what you maybe know from blockchain being Bitcoin and Ethereum, these permission networks allow you to build logic and give different participants different access controls into your blockchain. So in a business scenario, you've got lots of participants. In our case, we'll talk about having a set of shippers and importers and moving the goods through the real world. All right, so I'll introduce you to my blockchain model. So Hyperledger, we've got an instance of it up in IBM Cloud. You can choose to use, I'll just jump over and show you this. So in IBM Cloud, if you sign in and register, there is a blockchain starter platform here, and you can create yourself an instance. It's free for the first 30 days. You do have to put a credit card in, and so be careful about charges there. You can also create yourself a Kubernetes cluster and deploy. So the first one is running up on a Z-Linux mainframe. You can deploy pretty reliably, very fast, the blockchain. The second technique is to set a Kubernetes cluster up, which I've done here, and I've deployed using the instructions the Hyperledger in different components in my cluster. And so here at the command line, I've got the blockchain pods all configured here, running the peer and the database and composer, and most important, the REST API. And we'll talk about the REST API, because ultimately, once you build a blockchain to interact with the blockchain as a developer, either you're a back-end developer or a front-end developer, you're going to interact through a REST API. And so the Kubernetes cluster gives us that and an interface. All right, so the first step after you've built the board, you've instantiated an instance of Hyperledger Fabric in IBM Cloud. You want then to build a model. Now let's go take a look at that. So what you do, and I'll just start from the very beginning here. Let's just jump to the very beginning. And so you can deploy a new network, and you see that I've already deployed one, but I'll take you through some of the steps. And so we're going to, this is Composer, and Composer is sort of a web IDE to help you construct your blockchain model, your chain code, and test it. So brilliant set of tools, tool chain to help you test and deploy and monitor your blockchain. So we're going to do a new one, and I'm going to go collect. And so I've already got it here. This is essentially a zip file, which defines what the blockchain is going to do. So we'll walk through it in a second. And I would select that, and I would go give it the proper permissions, and I would hit deploy. And what happens is you get to the point here where, let's go take a look at the model file, talk about blockchain. The definition of my perishable network, well, I want to track bananas and apples and coffee and medicine. And we're going to track some medicine through the real world because I wanted to associate this with call for code. So along the way, I've got a shipment, right? We're going to take my board and we're going to send the data up to the cloud. And the data that arrives is going to be location data. So we want to associate the location data with a shipment. And so we're going to connect two things. Accelerometer reading. So was this particular shipment, it's a crate of medicine, it's a crate of bananas. No one wants mushy tomatoes. And so was it jostled in the truck? Was it refrigerated? So what was the temperature along the journey that truck took? Maybe the medicine is only good within a certain range. Okay. And in both of these transactions, so accelerometer readings and temperature readings, we want to store three things. The environmental condition, so Celsius in the case of temperature. We want to do longitude and latitude, so where it is in the real world, and then time, right? So those three attributes, where, what, and when. Let's talk about the board itself. So I'm doing cell tower triangulation. So that the nice thing about the particle electron, it's got a SIM card on it, and the SIM card can talk to the cell network. So I'm here today in Vancouver. I turned on the board, and it found a network. I've traveled all across the world with this particular one down in Uruguay and Brazil and Europe. And Particle has a global SIM. This is a global SIM, and I can send data up to the cloud. And so now that's what I'm doing, and I'm going to get back cell tower triangulation. Cell towers are cemented to the ground. We know where they are, and if you know where 3 cell towers are located, you can do triangulation, not so much on the board, but up in the cloud. Tell me where it is based on signal strengths. I send that up. That's the data I'm going to send to the cloud. All right. So once it arrives, we want to, so we'll just scroll down to a shipment. And a shipment has a contract associated. So Hyperledger is all about a smart contract. And in that smart contract, you have a transaction history of temperature readings, a transaction history of accelerometer readings, GPS data, and then the mins and maxes. So for a particular shipment in this contract, I want to know what the minimum and maximum temperature range is, what the maximum accelerometer data can be subjected to, because there might be penalties that you can throw alerts if you exceed your contract. And so nice thing about a blockchain, it's immutable. If you so much as the truck breaks down, it hits lots of potholes, you'll know it, right? And so along the way, it's the trucker, it's the shipper, it's the distribution center. You know where the shipment was exposed to these extreme environmental conditions, all captured in a blockchain contract. And so that's the power of why a blockchain is useful, because I could have done the asset tracking in just a database. But where blockchain becomes really useful is when you have multiple participants, the shipper, the trucker, the port operator, the distributor, the retailer, you as a consumer. Is this product good? You can now look in the blockchain across all of those participants and know whether the tomatoes or the food that you're eating or the medicine that you're going to use has been safely guarded. And so that's why a blockchain becomes very powerful here. And then, of course, we define our participants and the address and so forth. So here we go. We've got now ourselves a blockchain model. We wrote some chain code wrapped around it. This is just some JavaScript that gets compiled into Go. And so there's a bunch of functions that you as a blockchain developer would create to manage the data and the transaction histories. Okay, we want to test it. So tell me about my contract. So here I've got a contract and I've got a set of shipments. So I've got actually 3. Let's go take a look at these shipments. So I've got 3 shipments, 4 shipments, which we'll talk about. And I'm going to show you the board moving around in the real world and a set of shipments that I created several months ago down in Puerto Rico. Nice thing about a blockchain is you can go and look at all of the transaction histories. So it's immutable. You can go and look and inspect every transaction on my blockchain. I can go and view a particular reading. This was today, earlier in the day. It was exposed to environmental conditions X, Y, and Z at a particular longitude, latitude, Vancouver, and global GMT time a couple of minutes ago. All right. Now, So that's kind of cool. We can see every transaction on the blockchain, interact with it. So this is just a great way to test as you build your model. Now you want to start to do something interesting with it. And that's where our REST API becomes very powerful. Because you and I don't want to interact as a developer. I don't really need to know the guts of the contract. I just want to be able to create a transaction, add it to the contract, and display it in some meaningful way. And so in the case, we take our blockchain model, and Hyperledger Composer takes your model and creates a REST API around it, for which you get now an open API Swagger doc, and you can do a post and a get of the transaction. Here's how to create a transaction reading on my blockchain, and you can test it out right from here. So all kind of clever. You can go and build yourself a REST API call. This is brilliant. I know what to do as an app developer. Just it's a REST API, a post and a get. And it defines the accelerometer readings and the temperature readings and the contracts and the demo. All right. So everything you needed that you defined in your blockchain model now becomes available through REST interfaces. All right, cool. Now let's go build something with this. And in my case, I wanted to go and build Node-RED. So I provide, I'll jump back to my instructions just to ground you where we are. So remember that in section 2, I built the blockchain. I deployed it in the container service. I've got my REST API now, which I can interact with. And now in my last section, I actually want to tie this together. And I'm going to do that with Node-RED. So let's go take a look and talk about the story. So in my story, tying it to call for code, remember back in September of 2017, Hurricane Irma and then Hurricane Maria came over Puerto Rico. And the island was absolutely devastated. Power was out for weeks and months, and there was quite a bit of human suffering. And so we wanted to ship medicine from San Juan to the other side of the island. And so we put the crates of medicine on a couple of trucks, and we said, go. We told them to take 3 different routes. Now, on the other side of the island, I had a coordinator for the medical supplies, and they had a bunch of patients that they wanted to administer this medicine to, but they weren't sure which truck arrived successfully, safely, within the parameters that I defined in the contract for temperature and accelerometer data. I wanted the medicine to be safe to administer. And so they were able to play back the transaction history of this particular journey as we put it on a truck. And the refrigerator on one truck was faulty. And so every couple of minutes, the temperature exceeded its threshold. And so we recorded that in a blockchain. And now I built an app here, which we'll talk about, that draws that journey on a map. And I drop pins along the way, defining where it exceeded the temperature readings for a particular truck. All right, we'll go take a look at that. And so what I did is, since this is a pretty big Node-RED flow, I kind of walk you through it. I broke it down into 7 tabs, and so we'll talk about Node-RED. Let me just go show you that. So Node-RED is a visual programming language, and you, from your palette in the left navigation, you can go grab a debug and an inject, and you can wire these 2 nodes together on your flow. And in my case, I want to inject a string, hello world, and say done, and then deploy. Oh, I'm going to be logged in for that. So let's go log in. You can now deploy your little test. And let's go take a look. We'll clear the debug tab. So on the right side, you've got your debug tab. And so let's go say, here's hello world. And that's great. So now I've built myself a simple 2-node flow to go do something. I'll mark those and delete them. let's walk through the tabs. What do we want to build? So let's show it to you live first. So we're going to build a dashboard that receives the data from the particle electron. We're going to write it to the blockchain, and then we're going to read the historical data off of the blockchain and then put it on a map. And it looks like this. All right, so we've got a couple of trucks. And so let's go pick a truck. And in my case, now you as an app developer, you're going to care about longitude and latitude. Your end user probably doesn't. Just give them the map. For our sake as a developer, I actually built a little table here. And let's go watch where this truck was. And so we're going to kind of navigate down a highway in Puerto Rico. And we'll just stop that and we'll zoom out just so I can see where it was. So here we are in Puerto Rico. And this truck successfully made it to the other side of the island. Truck number 2, let's go track number 2 here. And so here's truck number 2. He takes a different route. He goes down by the sea. And so we're kind of just reading from the blockchain, and we're going to move our map along. And so he's going along, and every once in a while, he gets in trouble, and the sensors get temperature readings exceeding the contract. And so he takes a very scenic route along the way. That road was blocked. And so now let's zoom out. And so here we have a set of pins that says, this particular medical supply was exposed to some extreme conditions. It exceeded the safety of the medicine. Now, how did I know that? So that's the app. Let's go show you here this morning. So here's car number 1. This is me. Let's just go load that one up. And let's go track that one around. So here I am back and forth to the convention center in Vancouver today. And I was back and forth I keep looping through here. Okay. And we can kind of zoom in on that. And, here's my hotel, and there's the convention center. It's a beautiful city. Visit if you can. So now, it actually works. And I had set my temperature readings pretty low. And so it was comfortable here in Vancouver. All right, so how did this work? Let's go take a look at the Node-RED flow, and we'll jump through. So I don't want to spend hours walking through code with you, just an introduction to it. I kind of initialized the board. Here I tell you where my REST API is exposed and the access to my board. So I've got a token and a device ID so I can read off of this board. I can control turning it on and turning it off when I collect data. And now I'm going to receive data from the board itself. It's coming in through the particle IO, and I'm going to format that into the record. Remember, I got to build that REST API. And so I format my data as it's arriving, and then I say, go write this to the blockchain, for which is on another tab. And here I come. I'm going to build that transaction. And it's not surprising that this little bit of JavaScript looks very similar to the temperature reading post. Scroll down, right? So it looks very similar to this. And because that's what I'm building. I'm actually going to write now this data to my blockchain. And I build my Fabric API, and off I do. I do a post, and now it's written to the blockchain. I want to go play it back. So let's go. So I built a dashboard. Remember, I showed you the dashboard here live. I got some drop downs and a date picker so we can kind of hone in on dates. And then I've got a bunch of switches, whether I want to show environmental pins or geofences, send myself alerts when the asset moves in and out of my geofence, and send alerts if I want to track my asset. Okay, so here's some pins. And so I build in this tab here the dashboard itself, sliders and the map and the drop down and the date pickers. And so a bunch of Node-RED that control the logic of it. When you load the blockchain, so I'm going to read all the transaction history into my blockchain, and then now I've got an array of the blockchain data, right? The historical track that my asset took through the real world, and I want to play it back in a map. So this last tab ticks me through it. So you saw the asset move on the map, and so I just have a little flow here that draws the track, that moves the asset, that drops a pin, and drops it into the map. So that's what I'm doing on this tab here. Okay, so that's in a nutshell the three parts of how to build an IoT asset tracker with blockchain and Node-RED. Started with a particle electron. I built a Hyperledger Fabric and Composer in IBM Cloud, in a cluster, or in the blockchain starter plan. And then I use Node-RED. It's a Node-RED Node.js web starter that's running Cloud Foundry up in IBM Cloud. So this is hosted Force for Good med supplies. And so that's a URL. Okay. All right. So that's all fun. I'm going to stop and take some questions. I think we've spent about 30 minutes. So right on time. And
thank you, John.
Wow.
This is really awesome. And so, yeah, there are three questions. You should see them in Ask a Question panel.
Cool. So let me see if help me. So I see there's a question about cost.
Yeah. So this one was at the very beginning, I think, when you were showing the service and the cost. So this question is, in that context, if there is any way to predict.
Yeah. So there's two paths. So the blockchain starter plan, free for 30 days, and then you get some credits actually. But when you sign up for IBM Cloud, you do have to run the blockchain starter plan in the paid account. So you need a paid account, not the free. There's a free trial account, which is brilliant. You can experiment with a whole variety of Watson services, not blockchain. Well, free for 30 days. After that, you get start charged. I think it's $500 a month per instance. So you do have to check. Well, if we want to share my screen, nice thing about our services here, just go share my screen again, and then just minimize. We jump over to our blockchain service. You all see that, right? And so there's a pricing plan. So here, so you get $500 towards your first starter plan, and then it's actually $250 per peer, right? 100. Anyway, so there's a pricing model to this. Okay, so just do be careful. And then, of course, if you don't want to use the enterprise scale blockchain, you can do it in a cluster, which I did here. Now, I chose the lowest cost cluster. Matter of fact, there is a free tier in the cluster. You get one node and one CPU. I forget what the size is here. You got one worker node and one pool. And anyway, so it was free. This one, it gets auto deleted if you don't use it. So you have to use it, or it gets garbage cleanup. And so there's two paths. So depending on your interest, experiment for 30 days and then delete it so you're not charged. Long answer.
All right. Thank you.
Back over to the Q&A. And I see there's a question about predictable. Yeah, so I did show you the predictable cost of this. It's not a per transaction. It is purely on the hosting charges. So we're not doing any proof of work here. It's purely, we're not charging per transaction or transaction history. It's all about the service. You build a model. We help you build it with Composer. Great. So yes, we are recording this. Come back and view it again and again up on IBM Cloud videos. All right.
And John, are you able to see the other questions in the?
Let me see. I'm trying here. Satellite connectivity. So the question is whether this asset tracker can use satellite. So yes, this particular board, the particle electron asset tracker, has a GPS, so you can get global navigation, satellite system data, as well as your cell tower triangulation. So depending on how big you build your board, cool thing about cell tower triangulation, this can be inside of a truck, it can be inside of a crate, inside of a box, inside of a warehouse, and I can figure out where it is. If I use if I use the satellite system, it needs to be outside, so it needs line of sight to your GPS. Okay, so the question is triangulation. Now, GPS very accurate. Cell tower triangulation not so accurate. But if you just want to know it's moving down a highway, you don't care if it's on the center lane or not. It's kind of good enough. Because you're moving down a highway, it's already, if you measured it, it's down a highway a little bit more. Okay. Now, this particular board, maybe $100. I'm not a particle salesman. The SIM card, brilliant, right? So it's not your 20 gig data plan. It's 5 megabytes a month. Cost me $3, right? For $3, I can track a thing a month. So global SIM, very simple little data plan, cell tower triangulation, very small amount of data that you send, right? In my case, temperature readings every minute. And all of that's programmable. GitHub. So thank you for posting the Git repository links. There's some other questions. Any other questions here? Yeah, so let's wrap up with call for code. So I just built a thing that tracks a medicine. There's so many use cases for call for code in natural disasters. Where is your assets before and after? So staging, knowing that a hurricane is coming or a wildfire is raging, you can pre-deploy assets. Where it is. Where is that generated? How much gas does it have? How many hours has it been running? Where is it now? And get that data up to the cloud so that you can do asset management, both predictive maintenance or just preparing for, hey, it's running low on gas. There's a generator out in the field. We know where it is. Make sure someone brings gas to it before the generator runs out of power. Cool. So Max, let's wrap up. And
yeah, John, do you have, maybe there are 3 more questions. Maybe you can spend like 5 seconds on each. There's one question: is IBM working with Swift and blockchain?
So IBM has certainly running with Swift. So we can run Swift on Linux in the cloud. Swift, of course, running on iOS. I've not heard of a Swift blockchain project, though there might be a model, being able to write the model. Right now I showed you JavaScript, and underneath, of course, is Go. I'm not sure if there is would have to check for you. Next question.
All right. Reading the other questions, I think they're going to take more than just 5 or 10 seconds. So maybe I'll get the questions and maybe we can answer them in a blog post. What do you think?
Yeah, perfect. Sure. Or
that's going to be
reach out to me at John Wallachy on Twitter. Find me on LinkedIn, or post in as a Git question, Git issue on my repo.
All right. Well, thank you. This was really good. Thank you, John. Just very quickly, so this, as I mentioned, this is our 5th webinar in the series. We have one more coming up next week on September 5th at the same time. And the topic will be how to build a financial network with blockchain to execute secure transactions. So we hope to see you next week as well. And again, thank you for joining us. Reach out if you have any questions. We'll see you soon. Bye.
Bye.